almost every moment of every day, we encounter situations calling use of our mental faculties. Often we have to think and act quickly. A moment of decision, of split-second thinking. Impossible? Not at all. For this driver possesses the finest of all thinking organisms, the human brain. The brain, a pulpy mass of cells and fibers, is the center of the network of fibers that make up man's nervous system. Extending upward into the skull, the spinal cord widens to form the brain stem. The brain stem controls actions of the body that are automatic and therefore do not have to be learned. For example, the medulla controls a number of automatic, vital functions of the body, such as the action of the heart, the action of the muscles of respiration, the action of the digestive system. At the base of the skull lies the cerebellum. The cerebellum assists the cerebrum in coordinating complex muscular activities, such as this. But the cerebellum does not originate the impulses that direct our muscular behavior. It simply transmits impulses that originate in other parts of the nervous system, particularly in the most complex and highly developed part of the brain, the cerebrum. The cerebrum is the center of human intelligence. It controls learned and conscious behavior. In a newborn child, the cerebrum is still undeveloped. The child has all the reflexes and automatic responses, but he cannot respond to all stimuli. He has to learn these responses. And in man, in the conscious state, much behavior is based on learning. For example, the functioning of the cerebrum enables a child to learn to walk.
I'll go over and help Carrie walk here, huh?
But if a child's cerebrum fails to develop normally, he may not learn these responses.
Can Carrie walk?
No.
He can? What does he do?
Man's capacity to make learned and conscious responses is determined by the cerebrum. Outwardly, the cerebrum is a pulpy gray mass with deep folds and convolutions. In cross-section, it is shown to have a thin outer layer of gray matter. This is called the cortex. It is composed of the nerve cells of the brain and is therefore the most vital area of activity. Beneath this is a mass of white matter composed of fibers extending from the nerve cells or leading to them. These transmit impulses from the nerve cells throughout the brain and out to the rest of the nervous system. They also carry impulses from the sense organs to the cortex. Each half of the cerebrum is divided into 4 lobes. These are the frontal, parietal, temporal, and occipital lobes. These regions perform a number of specialized functions. Visual stimuli are received in the occipital lobes. Sound stimuli are received in the temporal lobes. Taste stimuli are received in the parietal lobes. Touch stimuli also go to these lobes. In the frontal lobes are located the motor areas controlling movements of the body and, above all, the organs of speech. These centers perform the primary functions of the brain: perception and the control of acts or behavior. Neighboring areas of the cerebrum perform its secondary functions: analysis and integration. They control language and skilled acts. These centers are located in most people on the left side of the brain only. The intricate workings of the cerebral cortex can be demonstrated in the situation we have already observed. Everything the driver sees and hears comes to him as stimuli, which are received by his visual and auditory sense organs. These send impulses back along the neurons to the areas of the cerebrum concerned with sight and hearing. This is the first station, the place where he actually sees and hears the car, but he does not yet recognize what it is. For this, impulses go on to the second station, the areas concerned with analysis. Here, memory comes into play, and drawing on the stored images of past experience, he recognizes that this is a car and understands the meaning conveyed by the car and the horn. But it still remains for him to make a response. For this, the impulses go on to the third station, the areas concerned with planning and the elaboration of responses. Here, the stored images of past experiences are projected into the future. This stimulates him to select an appropriate response. This is conveyed back to the areas controlling body behavior. From these areas, impulses are sent to the appropriate parts of the body, and he responds. These are the steps involved in every act of conscious behavior. First, reception of the stimulus. Second, recognition of its meaning. Third, interpretation and planning a response. Fourth, direction of the response. The existence of these steps is revealed by what happens when any one of these areas of the cortex is injured or removed. For instance, if the areas of analysis are injured, we may still see or hear as before, but we cannot understand the meaning of the stimuli we receive. Here is an individual suffering from an injury in these areas.
What these words are?
Cat.
She can read and copy written words, but she cannot write down words she hears.
Fine. I want you to write this sentence for me. I have a hat.
Yes. 2 girls and hat.
That's fine.
This is the result of a breakdown in the area of analysis that prevents her from recalling the visual images of spoken words. It is the swift and easy movement of impulses throughout the cerebrum that enables us to think. But this must be established through learning and reinforced through practice. For instance, most people are capable of playing the piano, but like other skills, this form of behavior has to be learned and then strengthened in practice. This enables man to make the fullest use of his cerebrum. But for full expression of man's thinking capabilities, we must look to the whole brain functioning as a unified organism, thinking a problem through and making the right responses. The driver in this situation has to think through such a problem, to make a decision that may mean life or death. An oncoming car, no chance to drop back. Danger there, clear there. How is his mind working? He receives these stimuli, recognizes their meaning, then interprets them in terms of past experiences projected into the future. First, out of his experiences as a driver, he foresees what will happen if he fails to turn off onto the right or left shoulders of the road. Should he go off onto the right shoulder? He recalls the unpredictability of youngsters riding bicycles. This arouses the fear of what might happen if he struck one of the boys. Should he cut over to the left shoulder? He remembers frightening experiences with soft shoulders. This prompts him to foresee too clearly what might happen there. Which chance will he take? Now our man has to make his decision. To use his cerebrum to plan ahead and elaborate his responses, his choices. Which response to make? Not all problems are as exciting as this, but most are far more complicated, and all require the same functions of the brain. They require swift movement of impulses from center to center throughout the cerebrum as it performs these functions. The primary functions of perception and motor control, the secondary functions of analysis and integration, and most important of all, the functions of planning and directing responses. For in all of